Okay, so in this video we're going to look at magnetic locks and how we approach picking them. Someone on the LPU Discord was asking about resources for getting started picking magnetic locks, so I thought I'd have a go at putting something together for everyone. I've got some examples of different magnetic locks on the map, and we'll look at tools and the different types of locking elements and how we approach picking stuff like this. First of all, talk about what we're not going to cover. So this key has a magnetic element in it, but I would not class this as a magnetic lock for purposes of the discussion here. Basically this element is in there to add some protection against bumping and raking and stuff like that, and it helps with key duplication as well. So to defeat this, you can either just set a magnet in there when you start picking it, or you use something like this to just pull that element down. It doesn't really need to be manipulated like the locking elements in these other locks do. So while locks like this exist and they have magnets in them, you just defeat them with a magnet. Basically, you don't really need to listen to the feedback in these. So we will put that one to the side. Start looking at tools. So the main thing we need when picking magnetic locks is a pick for magnetic locks. So I have a couple here. You make these yourselves. I don't think anyone sells a commercial one, but they're very easy to make. This is it was a wave rake that I chopped the end off. And this was, I think, maybe a snowman or something like that. I've ground the end away. The main thing on these is they have a magnet glued to the end. So these are a 2mm by 1mm neodymium magnet. You get them in packs like this. Keep these away from animals and small children, obviously. But when you make these picks, you get an old rake or whatever, take the end off and just kind of round it over with a file or a bit of sandpaper. Put your magnets on, and you want opposite poles, so you want these stick together. So this pole is the opposite to this one. And the reason for that is keys like these that have magnetic slider elements in them. Each of these have a polarity, and these work by sliding something in the lock in and out, which we'll see shortly. But obviously if you use the wrong polarity pick, you're just going to push it further into the housing and not be able to pick the lock. So yeah, these are fairly straightforward to make. They don't need to be anything particularly special, just an old pick. If you're going to buy these, I'd suggest maybe a half ball or a ball rake, something like that, just because it gives you a little bit less material to have to worry about on the end. But yeah, I've been using these for years. They're fine. Occasionally the magnet will come off, just glue a new one on the end. I'm actually just using super glue. Like the magnet will hold itself to the pick, you're just using glue to really support it. So put those two there, and then I'll do this one next then. So this is something I made to pick locks with rotors in, and it is just two opposing pole magnets in this little 3D printed housing. This I made for the Dissect lock, which again I've got a video on that one, but this has a series of rotors in, which I'll cover what those are shortly, but you can use this to sort of rotate those to the correct orientation. And it just mimics one element in the key, basically. You may or may not need something like this, but yeah, they exist, and if you want to 3D print one of these, then you can. The other type, which is, these are the two that I use the most, and then this is the type of pick that is probably my next most used. It's just an ejector pin with a magnet on the end. So something like this, the Capital Magnetic Cam, you can pick this just by wiggling the magnet around like this. You don't need to worry about polarity too much because these have routers in, again, which I will describe what those are shortly. If you ever do need to change the polarity, just turn the magnet around. And you can improvise these from pretty much anything. I'm using this because I have it. You can use an Allen key stem or anything like that, really. Magnets themselves, 2x1mm is probably my most used size. And then I've got these, which I think are 5mm by 2mm or 3mm. And they go up in size from there, but to be honest, most of the locks you're going to want 2 mil max, maybe even 1 mil, depending on the lock you're picking. But if you were going to buy any, I would suggest something like this, the 2 mil by 1 mil. Get rid of that one. And then finally for tools, we have this magnetic viewing film. This is optional, but it is quite nice if you want to just have a look at how the key works. So if we put this on the MCS key here, you can see this gives you the bitting of the key. It doesn't tell you what polarity these are, so each of these magnets will be a different polarity, but it shows you where the elements are, it shows you the indication of them. So this can be quite useful, especially if you have something a little unusual like this lock. You can't really see the polarity on that, but you can see it on the key. If you put the key on, like, you can see that it's got these magnets on there. Yeah, so this, you can buy this off eBay or Amazon or something like that. It's just called magnetic viewing film. I've got a piece out of this one, but yeah, it comes in sheets of various sizes. And then let's cover this. So the feedback for magnetic locks is not by feel, it's by sound. So they can still be jiggle tested, but the way you do that is by listening to the element inside the lock. And something like this is a guitar contact mic. And a little amplifier with a headphone output. Something like that can be really, really useful for making that feedback more obvious. So if you're like me, my hearing's not the best, and I sit in an office with like fans and other stuff going as well, and background dog noises, something like that, which if you watch any of my magnetic lock videos, I normally have just attached to the vise. It'll amplify the feedback and just make it a little bit easier to listen to what's going on in the lock. And then last thing, something like that we don't really talk about much but should be talked about, is how you tension these locks. So some of them, like this Miwa, are fairly straightforward. You can just use like a normal sort of pry bar type tool. Others, like this, you really need to make something for these. So this is where having access to a 3D printer can be really invaluable. The hard part of a lot of these locks is tension control. So these work in the same sort of way as a pin tumbler, in that you need to set each element individually, but especially something like this where the tension is applied by rotating the core, there's a very fine point between nothing binds and everything binds, and you need to really be able to control that. So for this lock, something this sort of size is ideal. For something like the mag lock, which I don't have on the bench at the minute, obviously the bigger the dial, the more control over that like rotational position you have. So yeah, just something to bear in mind if you end up with something like slightly unusual like this, or the Capital Cam or the mag lock. Think about how you get tension into them, because it can make a lock very easy or very hard if you don't have perfect tension control. So let's have a quick look at these, and then we will talk about the locking elements in them. So this Miwa is the EC. This has a ball bearing detent on the top, which just provides like bias to the core. Some versions of this have some pin tumbler stacks at the top as well, but this is a slider lock, so there are these magnetic elements in the key on both sides. Get my viewing film out, and you can see not all of these are populated. There's 3 on this side, and there's 3 on that side as well. So yeah, there's more elements in here for master keying and stuff like that. The way this works, when you put the key in, obviously first of all it raises that ball bearing detent out of the way, and inside the housing are various sliders that have a magnetic element on it, and the key just pulls those into the middle, which allows the core to turn. So each of these will have a different polarity, which you can figure out by just running a pick down it, and if it sticks you have the opposite polarity. If it repels, then yeah, it's the same polarity. So I don't know what polarity these picks are, I've never needed to figure it out, but yeah, as long as you have the correct polarity for the element that you're trying to manipulate, you'll be able to manipulate it using one of these. So those are sliders, and I will draw what these look like in a minute, and I'll also put some pictures up as we're talking through. I'll probably overlay those kind of here, I guess. This is the Capital magnetic cam. This has rotors in it, I think. So rotors are little spinning discs with a gate or multiple gates in them. and when you put the key on, it rotates those to the correct position so that the gate lines up with a locking element, and then it allows the lock to turn. So this, look at it under the viewing film, it just has a couple of magnets on it. You can kind of see the lines in between them and the different polarities and the orientation of the various elements in there. This is similar, just on a bigger scale. Again, there's some rotors in there. This is a version of the Maglock. It's not a Maglock, it's something else, just a dependable brand, which is technically from Switzerland. And I'll move that one out of the way because it does take quite a lot of space on the map. This is another rotor lock. This is the Daisac magnetic padlock. You can kind of see the elements through there. If we get the key out, you can see them. There's one up here as well, which I can't see because I've cut holes in my viewing film or something else, but these are the rotor positions. There's 4 in here. There's a version of this with 6 rotors as well, and if you want to see more about how you pick this, I have a video on it. Essentially, when you put the key on, it aligns all the rotors to a position where their gate is such that there's a locking element that moves this way inside, and when you pull this out, it allows that to slide down between the gates, and then the lock can open. And then we have the Ever MCS, which is probably the hardest magnetic lock out there at the minute. This one is soft bricked. I've got the key control stuck in here, so the key doesn't go in that side, and it doesn't go in this side either, which doesn't turn because this side is blocked up. But if I was able to show you turning, I would. Again, I have a video on this already. This has 4 rotors on each side, and these have true and false gates. And because there's 4 on each side of the lock, when you are manipulating one, you are releasing tension a little bit, and it can influence the rotor on the opposite side or the rotor next to it. So picking this is hard, to be fair. This is black belt 3 on the LPU scale. And to pick this lock, you need special magnetic shielding material, which you put down one side of the key, one side of the core, sorry, which you use to try and stop the magnetic field from your pick influencing the sliders on the other side. And you use a pick. You wiggle the rotors around in there, and eventually, when you line all the true gates, the lock will open. So now that I've talked about true and false gates and sliders and rotors and all this stuff, let's bring in a piece of paper and I'll attempt to draw some of these. And then we'll talk about the feedback you get from the lock, and I'll overlay some images and we'll call this a video. So those are the tools. Those are very straightforward to make. If you want more information on how you make those, feel free to comment below. Anyway, a slider is fairly straightforward. So we have the plug in a lock, and obviously the key would go in here, and then you have the lock housing, and you have elements like this, and they slide either this way or that way, and they have a magnet stuck on the end. So these are normally sprung. So if we look at it the other way, the slider would look kind of something like this, and there'd be a magnet here and a spring here, which pushes the slider into the housing. And when you put the key in, if the polarity is right, it pulls this out so that it retracts into the middle, and when they're all attracted into the middle, the plug can turn. Rotors are basically a circle, and they have a notch cut in them, kind of like a Pac-Man, and they spin around a fixed point. Some of them can be biased with weights, some of them are biased by the magnets on them. Even it doesn't really matter, and they have 1 or more magnets on them, and these would normally be like opposite poles, so plus and minus. And then there's something else in our drawing. It'll just be a wedge. This is the locking element, and it will interface with this and allow something to either retract or move downwards or whatever. But obviously, if these I'll draw it, draw Pac-Man's mouth over there, and a locking element here. This wouldn't be able to move down because it would block on this rotor, but if you aligned it this way, this would fall into this thing and allow the whatever this is to move downwards. And these come in various formats. So the one in the MCS has, I'll draw it like this, because I'm very bad at drawing, but it has like a true gate, and then it will have a number of false gates around it as well. So they are, I think, in the MCS shallower. I will try and put a picture of this up here for you in a minute. So when you're picking it, you are aligning something into a gate, and then you'll figure out whether it's true or false based on the feedback later on. That's why this one is hard, because there's 8 of these and you have to find the true gate on all of them, and every time you release tension to move a rotor, you risk upsetting a different one. And that is really it. The 2 main types of these. There are other types of rotor. The Maglock has one that is more based on orientation, so like it will pivot like this or like this rather than rotating. It picks in the same way. You basically wiggle a magnet on it until you drag the true gate into the right place. Sometimes these will be arranged in groups, so something like the Gadget MRT will have, I'll draw them as Pac-Mans like this again. It will have, I think it's 4 rotors in there like this, and they have these notches cut out, and from a top-down view they have an element in the middle, like a pin that will drop. So if we also draw it the other way, you've got this pin, and then the rotors sit like this underneath it, and there's 2 behind there as well. So these only have a true gate, and you have to rotate them by manipulating magnetic elements which are on the bottoms or the tops of them until all these align and they form like this, essentially complete the circle around it. So these would be the rotors, and this is the pin in the middle, and when they all align around the pin can fall, and that allows the lock to open. But it's still a rotor, it still works in the same way. The feedback is the same, it's a slightly different design, but that's basically how these locks work. They're using something which you can control with a magnet, and to block something else from moving, kind of like pin tumblers, but using magnets. The interesting thing with sliders is obviously they can only, back to that picture, they can only be set or unset, basically. Unlike a pin tumbler lock where you can move them a specific height to get the different bitting, a slider can only ever be like pushed out or pulled in. Rotors are different. You can rotate those any number of orientations, and that's actually one of the, not weaknesses of this lock, but a way you can decode it is there are a specific number of rotations that are allowed per the spec. And yeah, you can go down these with a tool that Rain from LPU designed a while ago, and just try each possible orientation on each rotor. And as long as you don't unset the other ones, eventually you just decode the pitting that way, and then you can open it. But yeah, that's broadly speaking how these work. So let's talk about feedback. So the way you pick these is very, very similar to a pin tumbler lock. There are 3 different states for each of the elements. They are either binding, excuse my terrible handwriting, not binding, or set. And set can include like being in a true gate or a false gate, but the feedback for these different states is very, very unique. So binding is no sound. So the way you pick these, we use this one just for demonstration purposes with my magnet on a stick. You go around, you probably have your headphones on, you apply some tension to the core, and you give these a little wiggle. And apologies, I just don't have the setup to play audio over this, but you would be able to hear something moving inside, and it sounds exactly how you'd expect. It sounds like something, in this case, spinning. In the case of a slider lock, you can hear things moving inside, and the key noise you're looking for is that they spin freely. So if you wiggle this around, you'll just hear something spinning freely inside, and it sounds like something spinning. One of these ones, you can hear it moving side to side inside, and it sounds like something sliding. It's hard to describe it. When you hear it, you'll know what it sounds like. But if it's binding, then like a pin tumbler, it needs to be moved. There is no sound because it's pressed against something in the core, or something is being pressed against it, and that means that it can't move freely, so there is no sound. You might get a very muted sound, but more likely than not, you're going to get no sound at all. So if you, with no tension applied, wiggle your pick around, you hear it spinning freely in this case because it's a rotor. You apply maximum tension and then wiggle in the same spot, you will hear no sound. And that element is binding them. Not binding is sound. So it will sound like something moving freely in a lock. You can think of this like if you were picking a pin tumbler lock and you push on a spring that isn't a pin that isn't binding, it just feels springy. It's the same thing, but auditory feedback. And then you have set, and this one is a little different. It is more tricky to discern, but when you hear it, it makes perfect sense. So this sounds clicky, kind of like the, probably misspelled clicky, but whatever. Kind of like when you pick a Medeco, you have that distinct click when something is in the true gate. These, because of the way they operate, have a clicking sound to them. So especially something like this, where it's a big gate hitting a piece of metal, will sound like a tinny click. When you wiggle your pick, it'll click, 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 or like a very tinny metallic sound. Something like this, there's always a little bit of wiggle in there. So you'll hear the slider hitting probably the inside of the core, and it will make, again, like a tapping metallic sound, and it's very different to the unset not binding sound. When you hear it, and yeah, apologies, I can't play this over the audio, but you'll know what it is. So the way you approach picking these locks, you apply tension, you find the elements that are binding, you let off tension until they start to move, and normally there is some sort of feedback when they click into place. It might be a faint click, or they might just start making the set sound like a little clicky back and forth. Then you apply tension again and you test, and if you can go from no sound to the clicky sound and you apply tension, that element is set. And then you go to the next one and you try and repeat the same thing. You may well unset or drop an element, which, you know, next time you go to test it, it will either be binding or give you the not binding sound. And eventually, when you get them all to make the set clicky noise, the lock will open because all the elements are in the correct gate. Picking something like the Ever MCS, you will find that because it has false gates in, they will make the set noise, the clicky noise, and then as you set other elements and the core turns a little bit, you'll suddenly be binding in false gates, so they'll make the binding sound or not binding sound, and then you'll have to pick out the false gate and try and get into the true gate. But these are the three kind of fundamental sounds that you're looking for. Some of these, depending on the lock and the equipment you're using and all the rest of it, can be slightly different to ideal. You might hear, for example, a slightly muted click. That could mean that element is not set properly. It could mean that it's still binding slightly. In that sort of situation, I would suggest going around and trying the other elements first, and when you think they're all clicking, find the one that is a different sound. So it could be muffled, muted, not quite as obvious a click, and try and maybe manipulate that one. It sounds complicated. It's really not. Once you've tried one of these, you very quickly get the hang of the feedback, and then it translates to all of the magnetic locks, really. So yeah, I'm going to hopefully overlay some images of the various different elements on this. I will put them here. Credit to Rain from LPU for letting me use some of his images. He takes some really good high-res images. And yeah, I just don't have the time, unfortunately, to start gutting these and showing you what's inside. But yeah, that's a very high-level overview of how you approach picking one of these. I hope it's useful. If you have questions, hit me up in the comments or on the LPU Discord.